Penetration speeds of down-the-hole hammers depend directly on air pressure. The higher the air pressure, the faster they will drill. A typical compressor sucks in atmospheric air and compresses it to a much smaller volume, but at a much higher pressure. The higher the air pressure, the greater the volume of expanding air running to the hammer. So the piston must travel much faster to pass the delivered volume. If, for example, a compressor air pressure of 14 bar is selected, the compressor must also supply sufficient air volume to maintain that pressure. If the volume is too low, a lower operating pressure will be delivered. Increasing the compressor air pressure without an increase in air volume will not result in a higher hammer operating pressure. In choosing the compressor capacity, it's important to ensure that its output pressure and volume is within the operating range of the chosen hammer. Choose a hammer whose outside diameter is smaller than, but the closest to, the hole size to be drilled. This will allow the use of a nominal or standard bit diameter for the chosen hammer in order to achieve the best transmission of blow energy and optimum penetration speed. Drill tube diameter should be smaller than the hammer diameter, but as close as possible to it. The speed that the drilling debris is evacuated from the hole is important. This speed, or up-hole velocity, should be between 900 and 1800 meters per minute. If up-hole velocity is insufficient, dependent on drilling circumstances, there's a range of possible solutions. When you operate any type of drilling equipment, you need protective clothing, like a hard hat and reinforced footwear, for example, at all times. Never wear loose clothing, like a scarf, and imagine what would happen if it got entangled in moving equipment. And also keep hands well away. Where necessary, wear eye and ear protection. Always use safety chains on air hose connections to avoid the possibility of injury if the hose becomes detached during operation. When you're commissioning a new Halco hammer, keep the factory test certificate, spare parts list, lubrication details and commissioning instructions in a safe place. Each hammer is fitted with a spring-loaded non-return valve assembly to stop the hammer flooding when drilling underwater. In dry drilling conditions, you can remove the assembly to increase penetration speed. Bit retaining rings are manufactured as matched sets and should never be mixed one with the other. Always make sure the chuck outside diameter is bigger than the cylinder diameter in order to protect the cylinder from wear. When you commission a new hammer or fit a new chuck, always check the splines on the bit and the chuck for wear. Never try to dismantle the hammer using heat or by hitting the assembly. Think of the damage you could cause. When assembling a hammer and drill bit, always grease the splines with copper or lead-based grease. Chuck wear will be the greatest directly in line with the bit exhaust grooves. Index the bit to even out chuck and spline wear. Always check that hose couplings are tight. Air leaks cause pressure drops, Penetration rates will be reduced and fuel wasted. You'll also waste fuel and slow down penetration speed by using long hoses between the compressor and the rig. Fill the drill rig lubricator with oil of the right type and check it's working properly. Halco offers its own range of lubricators for most makes of drill rig. Down-the-hole hammer oil consumption is around 1/5 of a litre for each 3 cubic metres a minute of air consumed by the hammer. Halco recommends a 200 centistoke oil for the Mac hammer range, and our own specially blended HS200 oil is also available for this purpose. Oil with an antifreeze additive may be needed for working below 5 degrees centigrade. Halco Maxothene oil is available for these conditions. Before you start drilling, pour 1/3 of a litre of oil into the hammer. Don't rotate too fast, or you'll wear the bit and reduce its life. Use slower rotation speeds in hard, abrasive rocks. When necessary, lift the hammer and flush regularly during drilling to pass more air for hole cleaning on large diameter holes or where up-hole velocity is too low due to low air pressure or small diameter drill tubes. The feed force or pull-down weight on the hammer and drill bit shouldn't be excessive, as this may damage the equipment. Insufficient may cause the chuck to keep hitting the bit shoulder, causing damage to the components. Energy transmission to the rock will also be impaired. All Halco hammers are checked on our own test rig, but for the first hour of use, a new hammer should be run with 50% more oil than normal and at a low air pressure. This running-in procedure is also needed when new components like a piston have been fitted to a used hammer. When adding drill tubes, blow them through with compressed air before connecting up to prevent foreign matter from entering the assembly. When you take a hammer out of service, fit protective caps. Using foam with a down-the-hole hammer is very useful in some drilling situations. Mixing ratios depend on the application and the density of the material to be drilled. The amount of water and foam solution injected into the airstream will also depend on the size of the DTH hammer, the air pressure, and the application. Regular inspection, care, and maintenance of drill bits prolongs their life and reduces drilling costs. When transporting drill bits, don't throw them into the back of a pickup truck because damage to the buttons or foot valve may occur. Never allow tungsten carbide buttons to touch each other. This causes damage. Take care that the foot valve is correctly located in its housing, otherwise it could cause a hammer to malfunction. Make a note of the drill bit serial number and part number etched onto the drill bit shank before commissioning. Drill bits used in hard abrasive rock last longer if they're regularly reground. A DTH button bit can still drill with one or more broken buttons, but at a reduced penetration rate. Broken buttons should be ground off to prevent damage to other buttons. Remember that the bit reduces in size as it wears. If you need to replace a bit before the hole is finished, check that the new bit is the same size as the one taken out of the part drilled hole, but preferably slightly smaller. Periodically inspect the drill bit's striking end for damage and metal peening. There's a range of heavy-duty foot valves fitted with a stainless steel band. The heavy-duty valves last longer where high energy generated by high-pressure air and water attack the foot valve at the point where the piston hits the striking face of the bit. Regularly inspect the drill bit splines and remove any sharp edges or burrs with a file or emery stone. Heavy spline wear is usually caused by a badly worn chuck. Check the drill bit shoulder for damage caused by excessive feed force. Worn peripheral buttons and the loss of gauge steel on the bit head cause jamming, slower drilling speeds, and early button failure. Too high a rotation speed or insufficient flushing air cause buttons to wear quickly. Face buttons which are flat generally indicate lack of hammer blow energy, insufficient feed force, or poor hole cleaning. Excessive wear, particularly on peripheral buttons, will cause a rapid reduction in penetration speed, leading to wedging or jamming in the hole, and button failure. Flat widths should not exceed 3 mm to avoid heating due to friction. When operated and maintained correctly, Halco products will provide a long, trouble-free service life. Contact Halco for a complete operating and maintenance manual.